Welcome back. Problem example 1.6. This problem is taken from chapter number 1 stress and book name is Mechanics of Material by RC Hibbeler and 9th edition. The statement is the 80 kg lamp is supported by two rod AB and BC shown in figure. If AB has diameter of 10 millimeter and BC has a diameter of 8 millimeter, determine the average normal stress in each rod. So you can see this is the lamp clear, and that is supported by rod BC and AC, and the weight of the rod lamp is going to act downward. So due to this downward weight, there will be a tension in this AB and BC. As a result of Newton's third law, the rod will exert force on lamp in this direction. So I have shown this in free body diagram. The weight of the lamp is acting downward, and the force, this rod BC acting on lamp is FBC, while the force of rod AB on lamp is FAB. FAB makes an angle of 60 degree with the horizontal, while this FC, the ratio of the triangle, is shown as 3, 4, 5. So you have to determine the average normal stress in each rod. So let's start with the solution. The first step is that this weight is acting downward and weight is equal to mass into G. So mass is given as 80 kg and G is 9.81. So when you solve this weight acting downward will be equal to 784.8 Newton. Now we will apply equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So you can see that this FAB will have two components, one along x which will be equal to FABX component, and one along y which will be equal to FABY. Similarly, this FBC will have two components which will be FBCX, and one along y which will be equal to FBCY. So from here this minus FABX component plus FBCX will be equal to 0. So you can see that this angle is 60 degrees, so it's one component. Let this is FAB, so this component will be equal to FAB cos of 60 degree, and this vertical component will be equal to FAB sine of 60 degree. Why? How? Because if you take cos 60 degree, so cos 60 degree will be equal to this FBX divided by FAB. So FABX will be equal to FAB cos of 60 degree. Similarly, this FABY component will be equal to FABY. And same is the case if you take this component, which is, let this force will be FBC. So this FBCX component will be this one, and FBCY component will be this one. So for example, if this is theta angle, so if you take cos of theta, so cos of theta is equal to 4 divided by 5, and this FBCX component will be equal to FBC into cos of theta. So FBC into 4 divided by 5. This will be FBCX, and this FBC Y component will be equal to FBC sine of theta. So you can put the value of sine of theta. So sine of theta is perpendicular over hypotenuse, which is 3 over 5. So FBC Y will be equal to FBC into 3 divided by 5. Now you can just plug it in this. So FAB is this one. So I can write minus FAB into cos of 60 degree plus FBCX. So this is plus FBC into 4 over 5 is equal to 0. Let this become your equation number. This is your, let we name this equation number 1. Now we'll apply another equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So one upward force is this one, which is equal to FAB sine of 60 degree. Another one is this FBCY, which is this one, plus FBC into 3 over 5. Clear? And the downward force is weight, which is minus 784.8 Newton. Their sum must be equal to 0. So I can rewrite it this FAB into sine of 60 degree plus FBC into 3 over 5 minus 784.8 is equal to 0. So it means that your this FAB into sine of 60 degree will be equal to 784.8 minus FBC into 3 over 5. And this FAB will be equal to 784.8 minus 3 by 5 times FBC divided by sine of 60 degree. Clear? So this is your equation number 2. Now put equation 2 in equation number 1. So this is your equation number 1. So FAB will be replaced with this. So minus 784.8 minus 3 over 5 times FBC divided by sine of 60 degree into cos of 60 degree plus FBC into 4 over 5 is equal to 0. Now you will get this equation. So if you solve this equation, so you will get FBC will be equal to 395.2 Newton. Now put the value of this. Put FBC is equal to 395.2 Newton in equation number 2. So you will get FAB is equal to 784.8 minus 3 by 5 multiplied by 395.2 divided by sine of 60 degree. So you will get this FAB will be equal to 632.4 Newton. Now you have forces in both the rods. So we will go towards the average normal stress in each rod. Since rod AB and BC both are in tension, so we will find for rod AB, average normal stress in rod AB will be equal to force in rod AB divided by area of AB. So force in rod AB is 632.4 Newton and diameter of rod AB is given as 0.01 meter. So pi by 4 d square. Let me write pi by 4 d. Diameter is 0.01, not 001, 0.01 square. So when you solve this, you will get the average normal stress in rod AB comes out to be 8.05 megapascal. Now for rod BC, we have average normal stress in rod BC will be equal to force in BC divided by area of BC. So force in BC is 395.2 Newtons. Clear? And area is pi by 4. What is the diameter? So diameter is given as 0.008. So pi by 4, 0.008 square. So when you solve this, you will get average normal stress in rod BC is 7.86 megapascal. So that was all about this average normal stress in rod AB and BC. Now what if I represent this average normal stress in rod AB? So let this was the rod, clear. For example, this is the rod having this diameter, clear. So this is the load FAB. This is FAB, which is equal to 632.4 Newton. And if you want to represent this element, clear, stress on this, so the stress will be like, for example, this is the same rod AB, so stress on this rod will be like this. And if you represent them on element of cubic element, so this stress will be tensile. It will be like this, that is 8.05 megapascal. Same is the case, you can draw the stress and force diagram for rod BC. So that is all about this problem, example 1.6. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.